Good morning once again, students. This is Say once again. We want to have a quick lesson on gases this morning. So, this is the first time some of you may be hearing this as a topic. For others, you know this to be a state of a change of state of a substance from solid to liquid, liquid to gas. And today we are looking at gases as a topic and part of our thermodynamic heat topic that we studied before you went home. So let's begin the lesson with an introduction. Gases are known to be fluids, okay? And these fluids have molecules in them. So gases have molecules. They are made of fluids. Gases are made of fluids, and these fluids have molecules in them. Okay. The thing is that the molecules of gases are spread as far apart as the container in which they are contained will allow them. So the average molecular kinetic energy is too high for the intermolecular forces to hold the molecules together. I'm saying it again. The average molecular kinetic energy of a gas is too high for the intermolecular forces to hold the molecules of the gas together. The shape and volume of gases are decided by the container in which they are kept. The behavior of a gas is based on the relationship between the volume, the temperature, and the pressure of the gas. I just said that the behavior of a gas is based on the relationship between the volume, the temperature, and the pressure of the gas. So these relationships are expressed as gas laws or gas laws. That is why the behavior of gases as a result of temperature changes, as well as changes of certain physical quantities will be discussed as we move ahead in this lesson. Now we want to proceed by looking at the kinetic theory of gases. Okay, we mentioned something about the average molecular kinetic energy of a gas being too high, being the reason why intermolecular forces are unable to hold the molecules of gases together. Okay, so the kinetic theory simply relates the microscopic property of a gas. Okay, so it relates the microscopic property of gas molecules, well, such as their speed, the speed of the gas molecules, the mass of the molecules, the volume, the temperature and pressure, and possibly the kinetic energy of the gas molecules. To understand how these properties are related, certain assumptions have been made. Okay, now these assumptions were not made by Sir Evans. All right, so don't say A, Sir Evans. But then these assumptions are generally referred to as the assumptions of the kinetic theory of gases. Basically, this is what we are looking at, the assumptions of the kinetic theory of gases. And we want to discuss these assumptions so that by knowing these assumptions, we can tell the kinetic theory of a gas. So we want to proceed now to look at some of these assumptions. Okay. Now, one assumption we want to look at is what I've just written. The first assumption we want to consider, or the first assumption we are considering, is possibly the fact that it is assumed that a gas contains or consists of a larger number of molecules which are identical. And note that this is an assumption, okay? So, assumption number one for the kinetic theory of gases, the first assumption we are making this morning is that a gas consists of a large number of molecules which are identical. I hope we have that. Again, the second assumption we want to make for the kinetic theory of gases, the second assumption we want to make is that the gas molecules move with a range of speeds. Okay? Yes, the gas molecules move with a range of speeds. So you realize that sometimes it is growing too high, moving too fast, and at a point in time it's also moving slow than you expect. So here the assumption is that the gas molecules move with a range of speeds. Notice that speeds is in plural. This is our assumption number three. Assumption number three states that the volume of the gas molecules is negligible compared with the volume of its containing vessel. Okay, so it means that the volume of the gas molecules is negligible, it's short, all right, compared with the volume of its containing vessel. All right, so what it's simply trying to say is that the volume of the vessel containing the gas is greater, and the volume of the gas within the vessel is smaller, minute, or probably negligible. Okay, so this is our assumption number four. Our assumption number four with respect to the kinetic theory of gases makes us aware that the collisions of the molecules, okay, the collisions of the molecules with each other and the container walls are perfectly elastic. By now, you should know what elastic means. Okay, so our assumption number five says the attraction between the molecules is negligible. We're still referring to the gas molecules. So the attraction between the gas molecules is negligible. Okay, so this is our next number six. The assumption number six for kinetic theory of gases states that the duration of collision is negligible compared with the time between the collisions. Okay, so lastly, we would say that assumption number seven says between collisions, the molecules move in a straight line at constant speed and the motion is random. All right, so these are the seven known assumptions that define the kinetic theory of gases. So I believe that you will have to take your time and study these assumptions very well for yourself. Assumption number one for the kinetic theory of gases. Number one says a gas consists of a large number of molecules which are identical. Number two, the gas molecules move with a range of speeds. Number three, the volume of the gases or the volume of the gas molecules is negligible compared with the volume of its containing vessel. Number four, the collisions of the molecules with each other and the containing wall or the container walls are perfectly elastic. Number six, the duration of collisions is negligible compared with the time between the collisions. And finally, assumption number seven says that between collisions, the molecules move at or in a straight line at constant speed and the motion is random. Thank you so much. Thank you so much. Hope to continue the part 2 of this lesson on gases in your next video. See you all.